Hi, 7th graders. So yesterday in Zoom, Miss Underhill and I kind of talked you through the top of page 10, right? So we filled these out together, and you were supposed to go through and work on 10, 11, and 12. So what I want you to do right now is stop! You need to finish pages 10, 11, and 12 before you watch this video. Okay? This video is the end cap, not the beginning, which is a change up from what we usually do. So, once you've hit pause and finished 10, 11, and 12, now I'll get started with the video. We are looking at complements of an event. So, the complement, ooh, that's a word I am familiar with. I feel like I'm having, it's all coming back to me now. A complementary angle, that was two angles that added together, they completed each other, that equaled 90 degrees, right? Oh, the complement of an event, so not of an angle, but the complement of an event is all the outcomes in the sample space that are not included in the event. It's what completes it, right? So the symbol, here's that apostrophe, that symbol can be used to indicate the complement of an event. The sum of the probabilities of an event and its complement is 1 or 100%, because the event will either happen or not happen, okay? So the probability of the event plus the probability of the complement of the event is equal to 1. It completes it, right? So whatever is equal to 1, the top of the fraction is equal to the bottom, right? 9 over 9, 6 over 6, 3 over 3. The numerator and the denominator are equal. So that's what we're looking for here, is that fraction that equals 1, or it equals 100%. Okay? So if we are looking at the experimental probability, the probability of getting heads is 3 out of 10, right? The complement of the event, well, 3 plus what equals 10? There's your complement. 3 plus 7 equals 10, so 7/10 would be my complement, and that gives me 1, 10/10, right? The theoretical probability is 1/2. What is the complement? What adds to 1/2 to make it 1? Well, another 1/2, right? So 1/2 plus 1/2 equals 2 halves, which equals 1 whole. All right? So what we're looking at is what completes it. Remember? Oh, here's my little heart, right? What completes it? What makes it whole? So the weather forecaster predicts a 20% chance of snow. What's the probability that it will not snow? What makes it up to 100%? A 80% chance, right? So if it's a 20% chance of snow, there's an 80% chance it won't snow. Number 2, the probability of spinning an event number is 45%. What is the probability that you would roll an odd number? Well, that would be 55%. Why? Because 55 plus 45 equals 100. Now listen, I am not above pulling a calculator out and going, okay, 100 minus 45, just to make sure. Oh, there we go, 55, checking in on myself. All right, I'm going to need it for this one. The probability of winning the raffle is 0.005%. But even knowing that, I still buy those raffle tickets because I think, oh, this could be your time, Christine. Never is. Never is. So what's the probability of not winning? Gosh, I should tell this to myself. 100, remember 100%, minus 0.005. Oh, the probability of not winning a raffle is 99.995%. So you're saying there's still a chance, right? Okay, Yvette, use the spinner shown. Write your answer as fractions and percents. So the probability of getting an A. Okay, well, first of all, I need to have my whole. How many options are there altogether? 1, 2, 3, 4, 5, 6, right? So my denominator is 6. Then my numerator, right? How many A's are there? 1, 2, 3, 4. 4, 6. Can I leave it like that? Wah, wah, wah. Nope. Okay, because it's not simplified. What can I pull out of the top and the bottom? Divide by 2. They're both even. If I do it to the top, I do it to the bottom. 4 divided by 2 is 2. 6 divided by 2 is 3. My answer is 2/3. Now I need to write it as a percent. So there's my fraction. 2 divided by 3 is equal to 0.66666, repeating, right? So if I were to do that as a percent, it'd be times by 100. I would end up with 66. If I rounded it to the ones place, it would be 67%. Okay, now the probability of getting an, oh, this is the part. See that little apostrophe right there? That's telling me what's the complement, what completes it, right? So if I have 2/3, what plus 2/3, remember my denominator is always going to stay the same, is going to give me 3/3, which is going to give me that 1 whole. So what would go right here? 2 plus what equals 3? 1/3. So my answer here would be 1/3. And then what percent would that be? Well, I would go 100 minus 67. Now, that would give me 33%. And if I did that, 1 divided by 3 is equal to 333 forever. And if I did times by 100, I would get 33. And if I rounded 0 through 4, the number stays the same. So if I rounded to the ones place, it would end up with 33. Notice they add together to equal 100%. These fractions add together to equal 1. That's the complement of an event. All right. What if Yvette spins the spinner 72 times? How many times would he expect to get an A? Okay, well, 72 times. Well, that would be, how many times would he expect to get an A? Remember, that's 67% of 72 times. Okay, remember this? Oh, hello, calculator. 0.67 times 72 is equal to 48.24, but I can't have like a 0.24 of a time. So how many times could he expect to get an A? It would be 48 times. Whoa, sorry. That bar is right here. Oh, isn't complements of an event so fun? I love it. Remember, the complement adds together. So the fraction adds together to equal 1. The percents add together to equal 100%. That complement brings it in. And then, remember, be on the lookout for that apostrophe, because that tells you right there, ooh, what do I need to add with the A? What will be the opposite, right? What's the probability of me not winning the raffle? The probability that it will not snow. The probability that I will not roll an A, right? Okay. Hey, good job, 7th graders. I'm so proud of you. I hope that helped, and I really hope you could have seen that the whole time. I'm going to feel, man, I was feeling so good about the video. All right, I'll see you guys later at Zoom.